is wavelength? Wavelength in a periodic wave is the distance from any point in one cycle to the corresponding point in a neighboring cycle, basically the distance between two waves. In order to understand wavelength, we must first discuss the different types of waves.
So waves transfer energy through oscillations. Remember, those waves can either be longitudinal, that's when the movement of the particles are parallel to the motion of the energy. In simpler terms, when the oscillations are in the direction of the movement of the wave. Or they could be transverse. That's when the movement of the particles are at right angles or perpendicular to the motion of the energy. In simpler terms, that is when the oscillations are perpendicular. In either case, the distance or the repeat distance between those oscillations is going to be the wavelength.
Now let's go over the parts of a longitudinal wave. Compression occurs when the wave is pressed together. This is when the wave has maximum density. Rarefaction occurs when the wave is spread out. This is when the wave has minimum density. The distance between the two compressions is a wavelength. A toy slinky is being used here to demonstrate a longitudinal wave. As energy is input horizontally into one end of the slinky, there is a movement of particles parallel to the motion of energy towards the other end.
Secondly, let's go over the parts of a transverse wave. Transverse waves look a lot like a roller coaster track. The trough is the lowest point on the transverse wave, and the crest is the highest point on the transverse wave. One wavelength occurs between two troughs or two crests. The vertical distance between the wave's central axis and the top of the crest is the amplitude. Here, another toy slinky is being used to demonstrate a transverse wave. The motion of particles in this type of wave is perpendicular to the motion of energy. The frequency is the number of waves that pass a certain point each second. The unit of frequency is measured in hertz and/or kilohertz, megahertz, and gigahertz for very high frequencies. The speed of a wave is related to its frequency and wavelength according to this equation, v equals f times lambda, where v is speed in meters per second, f is the frequency in hertz, and lambda is wavelength in meters. For example, a wave with a frequency of 100 hertz and a wavelength of 2 meters travels at 200 meters per second.
There are several types of waves that exist at differing wavelengths on the electromagnetic spectrum. Radio waves have the largest wavelength, ranging from 300 to 0.3 meters. Due to the inverse relationship, we see radio waves as moving at the lowest frequencies. Radio waves are typically utilized by the AM and FM radio stations as well as TV satellite broadcasting. Gamma rays have the lowest wavelength, ranging at 0.003 nanometers and smaller, and move at the highest frequencies. These waves are emitted by highly radioactive elements such as potassium-40, and in which the nucleus of the element suddenly changes its state to a lower energy.
Thank you for watching our video. If you would like to learn more about wavelength and other topics surrounding wavelength, please visit our website.
God dang it. Look at the passion he's putting into it. Come on.
Oh my God.